Hello, Aurora. It is Thursday, June 4th. I hope you're having a great week. So, we spent a day learning about the wind. That was Tuesday. Yesterday, Wednesday, we started to explore local versus global winds. And today, I would like to focus on some local winds, and those are called sea breezes versus land breezes, two very important types of local winds. So, this animation is going to give us a little bit more detail about that. Now, before we move into the local winds, just as a review, remember wind is the sideways or horizontal movement of air from kind of left to right. And it has to involve unequal temperatures, a warmer versus a colder area, which is going to cause high versus low pressure areas. And wind always moves from higher to low pressure, which we're going to show in this diagram. And of course, convection currents are involved because that's the movement of heat in a gas. So, some important things that both global and local winds have. So, this is going to be an animation of sea breeze versus land breeze. So, if we take a look on the left hand side where my mouse pointer is, that's the land, and we have the ocean on the right hand side. It's currently 12 o'clock p.m., about lunchtime. I'm sure a lot of us have been to the beach since we live near the beach in New Jersey. And the land is 85 degrees. That would include the air over the land as well. And the ocean is 65 degrees. That includes the air above the ocean too. So the land is about 20 degrees warmer than the ocean itself. I'm sure you've kind of felt that hot sand at the beach during the middle of the day. Well, the land is typically warmer than the ocean during the daytime. So as a result, since the land is warmer, there's going to be hot air over the land that's rising up. It's less dense, it rises. So we're going to call this a low pressure zone. So over the land is low pressure. Now, the opposite happens over the water. The water, the air is colder, more dense, and it falls. This would be a high pressure area. Now, that higher pressure, colder air falls, the warmer, less dense air rises, and we have a convection current happening during the day. You can see the direction that it's happening. It's going clockwise. But we want to focus on this colder falling air. It's falling and kind of going underneath the rising warm air. And we feel this on the beach. This is called a sea breeze. We feel this breeze if you're on the beach, and I'm sure you've probably been on the beach during the daytime. It can get very windy. This is why we feel this cold air coming off the water. Now, we call it a sea breeze because it's coming from the water. Wind is always named based on where it's coming from. So a sea breeze comes off of the ocean. Okay? Now, we're paused right now. The day doesn't always stay paused. So I'm going to advance it, pretending that the day moves on. And as the time moves on, the sun's beginning to set. And you can see that the land is dropping in temperature, but the ocean really keeps its heat. So it might take a long time to warm up, but it also holds that heat for a while. But the land, as the sun falls, let's go to midnight, the opposite. You can now see that the land is colder than the ocean. So we need to, first of all, get rid of some stuff here because this is not true anymore. And we need to explore what's happening now. So currently, the water and the air over the water is warmer than the land. What is it, by about 12 degrees? So the air is rising over the ocean. It's a less dense area, and we're going to call this a low pressure zone. The opposite's happening over the land. Okay, the air is colder, it is more dense, and it is falling. So we call this a high pressure zone. It's exactly the opposite it was during the daytime. Now we have a convection current again, but it's going in the opposite direction. It's going counterclockwise now. So now that cold air is still falling, but it's falling over the land, and it's coming and taking the spot of that rising warm air over the ocean. This is a land breeze. Okay, the breeze is coming from the land to the ocean. It's the opposite of a sea breeze. And we wouldn't feel any wind on the land. Well, first of all, it's 12 o'clock at night, so most of us aren't going to be on the beach anyway. But if we were, we wouldn't feel anything. We'd instead feel it if we were on the water, maybe on a boat, or for some reason swimming at midnight at the ocean. You would feel the wind coming off of the land, which is the land breeze. Now, there are also going to be situations, and let me get rid of this high and low pressure so we don't get confused here. There's going to be situations where there's not a temperature difference. So if I go back, going back in time, now 6 o'clock p.m., the temperatures are the same. Well, we would expect if the temperatures are the same, we wouldn't have a difference in temperature. There would be no high versus low pressure. And as a result, I always get this question, where would the wind be coming from? Nowhere. There wouldn't be any wind. When the temperature is consistent, we don't have wind. That's kind of everywhere. So if in your yard the temperatures are consistent, you're not going to have wind. But if there's differences, then we'll feel the wind coming from different directions depending on what's happening. All right, so this is a local wind. You got your sea breeze, you got your land breeze. There's also lake breezes that happen when land and water kind of are against each other, and we have those massive temperature differences that happen. Typically, a sea breeze is happening during the day, and a land breeze is happening at night. But it could be different. It all depends on the temperature. Okay. Now, global winds are over bigger areas, which is not going to be what we just saw. Global winds cover the entire earth. So I hope you learned something about land and sea breezes. This animation will be available to you with some other things as well if you want to play around with it. But have a good rest of the day and best of luck on your assignment.